they're kind of common, standard, if you like. They are going to be found on the unit circle. So if you have a copy of the unit circle handy, you will find that 240 degrees is about, I think it's that one there. Right. Do you remember looking at a unit circle, something like that, and you get 240 degrees?
Okay.
So you then go and you look and you find out that if you're on the unit circle, the sine of an angle is its y-coordinate. So if you want to find the sine of 240 degrees, you're going to find the y-coordinate of that point that's there. Right. So if I have a copy of a unit circle handy, okay, I'll just generate one. The angles go 30 degrees, 45, 60, and then the coordinates of the point at these three positions. Let's see, that's root 2 over 2, root 2 over 2 for that one. And this one is root 3 and a half, and this one's a half, and root 3 over 2. Right, and then you've got 3 more over here, and then you've got 3 more over here, and then you've got 3 more over here. So the guy that I said we wanted to get would be 240 degrees, which is here. And if you look at 240 degrees, what will that look like? It'll look like it will be that fella, so it'll be the small first one, so it'll be a half with a negative in front of it, and it will be the big second one, so it's that one. So you just trust me that 240 degrees is this point. So you want to find the y-coordinate. You're looking at that guy, negative root 3 over 2.
Okay.
So get a copy, print out or draw one of these guys with all the angles and all the coordinates. And then you can find the sine because it's the y-coordinate of the point. The cosine is the x-coordinate. And the tangent is what you get if you take the y and divide it by the x-coordinates. Okay?
Okay.
Anything else?
That was the main one I had problem with.
Okay.
What about the secant and cotangent?
Okay. Let's suppose, we'll keep the numbers the same, that you wanted to get the secant of 240. Well, if you go and look at that list, the secant is 1 over the x. So it will be 1 over negative a half. And after a little bit of work, you can find out that that's the same as negative 2. So to give you a quick summary of all 6 trig ratios, the sine of the angle will be the y-coordinate. The cosine will be the x-coordinate. The tangent will be the y divided by the x. Now the other 3 guys are called the cosecant theta, the secant theta, and the cotangent theta. That's the other 3 trig ratios. And they have the property that these are the reciprocals of the ones over here. So a cosecant is like 1 over a sine. The secant is 1 over the cosine. And if you take y over x and you find its reciprocal to z, you just switch places. So if I know this point here has these coordinates, right, I can find the secant, the sine, the tangent, the cosine, whatever I'm looking for, by some combination or version of each of these 2. The only thing you have to be a little bit careful of is that sometimes the fraction ones, especially some of these ones here, maybe that one there for instance, might come out a little bit weird. So I'll give you an example. Suppose you had a half over negative root 3 upon 2. Right? Now, you certainly can't leave it like that because that's really not going to, be exact value. The fact that they both have 2's, if you do a little trick, you can get rid of the 2's by multiplying by that guy. And so you've now got that fella.
Okay.
And if you do a little root 3 over root 3 trick, you've now got that guy. So some of them you may have to work a little bit on to get them to be an exact value that is a single fraction with no fractions top or bottom, right? Single fraction. And you try and avoid, whenever possible, square roots in the bottom as well.
Okay.
So how's things going, Olivia?
All right.
Homework going good?
Yeah.
We were just going over a couple of questions before the class started. Have you got any you're interested in? Hi, Skylar.
Oh. Can I?
You looking?
Yeah. Yes. Good.
Skylar, can you hear me?
Yes.
Okay, we're good. Someone, it's not my house, has got something in the background that's making a noise. It could be a television or something. If it's any of you three, you might want to put it on mute until you ask a question. That way it won't distract the rest of us. Because right now we're all hearing that and it might be a little bit off-putting.
Here, I'll just mute myself so that it won't be me.
Okay, so we're good. I guess I should start putting my video on so you all know I'm here. Do you like my background today? I got promoted. You may have noticed my new office.
There we go.
Yeah,
Very
not
nice.
bad. Considering I'm not an American citizen, my wife is saying I shouldn't be able to do that, but
Professor Robertson 2020.
I'm not sure I'm legally allowed to even apply for the job, so I probably won't. Hi, Chantel. How are things going? No, she doesn't hear me yet. Olivia, did you have a question? I know you were looking, but maybe you didn't find one.
Yeah, no, I do. Section 6.1, number 13.
Yes.
Yeah.
No, I just heard, oh yes, so that's a good question because at least two of you want to know about it.
Mm-hmm.
Is that the cow one?
That's the wheel one.
The wheel one before the cow one,
Oh.
right?
Yeah.
I'm going to hold off on that, Olivia, because that's one of the 6 questions I want to do today.
Okay.
The cow one is the second or 2 of those 6, so actually you're very good at picking the same questions that other people have had trouble with. So
Cool.
we'll be going over those 2.
All right.
I'm sure you're all aware by now that they randomize the numbers in these questions. So the examples I'm going to give are the numbers I happen to be working with, and you'll just have to adapt your question to the new numbers. The question's the same, right? But that's not 40, this is 60, right? That's not 22, this is 42. So you have to kind of tweak it to take that into account. The other classes I've been doing, have been giving me some tips and things that they found, because in a lot of ways I don't know what your experience is like, because my experience of WebAssign is I see all the answers and I don't get to see what the students say. So occasionally I'm not sure what your problem is. But they told us, for instance, in some of the questions, the software is quite nice to you. And by that I mean root 3 upon 2, or whatever the decimal version of that, as long as you put enough decimal places into it, it seems to accept both situations. But try and do the way the question is asked. By that I mean, if there's no mention of rounding off, you try and do the exact answer. So you try and write root 3 upon 2 or minus 7/15, so whatever it is. And on the other side, if it says corrected 2 decimal places, you can't leave it as root 3 over 2, right? You have to actually put it in your calculator and do it to whatever it is, 2 decimal places. So even although it may accept the wrong version, for want of a better word, they want a decimal, but it might accept the root 3 over 2 thing. It's good practice not to do that. Okay. So it looks like we've still got a couple of minutes. And how are you today, Carlos? Seems to be raining in your house today. I hope it's not a leak. He didn't get that one, did he? Hi, Daria. Hi, Ashley.
Hi.
Did you get that one that I said to you, Carlos? It looks like it might be raining in your house. No? Yeah, you got it. No, you can keep it on if you like. I'm pulling your leg. I don't know if that's an American phrase, but it's a British phrase. Do you use that phrase? If someone says, I'm pulling your leg.
Yeah, I'd say so.
Okay, so you know what that phrase is.
In
Yeah.
antiquity.
Oh, you try to say I'm old here. Olivia, you're not that old that I can't kick you out of this class, so you be careful.
Eh,
I have a question.
Oh, we do already. I've
Oh,
got...
wait.
Go.
I just like the like one of your lecture notes. I think you made an error.
Daria, will you turn your volume up because you're disappearing and I didn't catch most of what you said?
Oh, okay. Oh, I don't know. Can you hear me?
I can hear you better, yes.
Basically, on one of the lecture notes, I watched the 6.1 and it talked about the time and stuff. And so when you did, it's the one with the W, or like
The omega thing,
Way better.
linear and angular velocity. Yeah.
Like for one of them, you put in 2 seconds, like the time for the time, and then the other one you put like 5. And I was like,
Yeah, but I put deliberate mistakes in all my stuff just to make sure that you're paying attention.
all right.
So if it's something obvious like that, it's just me.
I was like,
I may have been looking at the question, then I turned my head away, and then I thought I saw a 2 and I wrote a 5. I'm getting old.
okay.
So it wasn't anything major. If you think that it is something that should be changed and you're not sure why, then certainly tell me. But if it looks pretty obvious, like, oh yeah, that should be a 5, then
Okay.
that's cool. And that does bring me to a general point. This coming Sunday, you've got to have finished all your stuff. I think one of them, some kind of review section, quiz, whatever it's called. It's like the last one in the list. Do you know the one I'm talking about? Yeah. We are not expecting, or I'm not expecting you to do the copy on the phone while you're working and send it to me. I think there's enough happening this week without, adding that. So will you just do that quiz in the usual way as if it was just another piece of homework that you just write your answers in and you're good to go, okay? Next week on Sunday there will be a test. I think it'll be called Chapter 6 test or something like that. And that one we will be doing in a more formal way, in which case there'll be a start, you'll do it on Sunday, and whenever you start, you have like 2 hours to get it done. And at the end of that 2 hours, it's like, time up everybody, you've done what you've done. And in that question, that's next, those questions, not this Sunday, but next. You'll also be using that cam scanner by then, and you will take pictures and turn them into PDFs, and you will upload them into the Canvas shell, where I've got a little thing called assignment, and you'll load it into that, and I will get to look at your working, and that will allow me to go back to that test and regrade it with some partial credit for those questions where you got the wrong final answer, but 90% of what you did was right, and you did, like I did, a 2 turned into a 5. And essentially the process was right. I just, I daydreamed or I calculated slightly wrongly. And if you don't, and there are a couple of reasons. The first one's the obvious one, is to help you. The software will just say you're right or you're wrong and hard luck, right? Even if you were 90% correct, it won't pay any attention to that. And so you wouldn't get any points according to its way of grading, right? It's in or it's out. That gives me the ability to look at it and give you partial credit. So your grade will always improve, or stay the same at least, but it will never get worse. And the second one is it's to stop cheating, obviously. There's a bit of randomization going, but if I don't see you're working, especially if it's what I consider a difficult question, and I don't see any working for it, then you weren't doing it. Someone else was doing it and told you the answer or something. I don't know. So that's just to keep us all honest. Well, I think it's time to officially start. I'm saying I'm going to record this. I'll put it on Canvas. There's a page that's called something like Zoom Meetings or something now, and I'll probably put it in there, and you can go and you can look at this. I'll also do some editing. In case I screw up, then I'll just cut it out and nobody will ever know, or whatever, right? So my goal today is to go through some homework questions that various people have given, and I've already got to 2 that I want to get started with, and that's pretty good because they were virtually the first 2 questions that people asked me anyway. And then after that, we'll make it a little bit open-ended. I've got 6 questions altogether that I've got set up that I want to go over because they seem to be the ones that various people from my trig classes were saying, can I get help on this? Those questions that are in that 6, you don't need to copy anything because I've actually got them written as a PDF, and after today, probably, to be honest, not until Saturday, I'll put them up online as a PDF and you can actually look at them in detail. So really, you just need to watch and say, why did you do this to get to that kind of question, right? And you don't need to say, oh, I'm going to have to write this down. That makes sense? On the other hand, if you ask me a question that's not in that 6, you might want to copy those down because I certainly won't have time to do everything. Now, someone's told me a trick, and I've had 2 different answers to this trick. One says that it works well, and the other says it's, do you know if you hold your space bar down, you can speak, and then when you take your hand off, it takes off the mute. And if it works well, it allows you to talk and then stop talking. But I think there's a little pause, so you may have to wait like 101 and then start talking. And the alternative to doing that is usually the one where you have to go up and unmute yourself and then back in. Right? I'm not sure we need that. If the class stays the way it is, I think it's small enough to just let you, come in and out as you feel. But, it is possible. So I'm going to pick a victim. Keelan, you ready? Hit the space bar, hold the space bar and see if it works.
I'm actually using my phone for this. So.
Okay, forget it. Keelan is not a good guy. Go for it, Olivia.
I'm pressing the spacebar right now. It works just fine. There's also the Alt+A keyboard shortcut to unmute yourself.
You got that, guys? Alt-A, unmute yourself. Strange combination, but it works. Spacebar seems to work fine, so...
And Alt-V is for video.
Oh, for making the video, that makes sense.
Yep.
Alt-A audio, Alt-V video. It is actually a sensible name now I think about it. Okay, is there any general questions about things, process and so on, not specific homework questions yet? So we'll get those out of the way first. Yeah, what you got for us, Daddy?
Is there like any way I can memorize the unit circle? Well, at least the radian part, because how the x and y's are seems.
Yes.
But like the radians, I'm like, oh,
Well, the unit circle's a big thing, so you're only like, 3-4 days in, so, I wouldn't be too worried. Maybe in a week from now, you should be worried if you still haven't got it in your brain. I guess it's like learning French. You just stare at the darn thing and you go over it until it sticks in your head. There is a formula for converting degrees into radians. I mean, if you just remember pi is 180, you can figure out most of the other guys as some fraction of pi, right? If pi is 180, isn't half a pi 90? Isn't a third of a pi 60? And things like that. A quarter of a pi, right, is 45, right, because it's a quarter of 180. So just remembering a key place like pi is 180, and then doing a little quick math in your head, you can get most of the other ones. Right? In fact, if you only memorize the angles between 0 and 90, which is called the first quadrant, do you know that you can get the other three by just symmetry and patterns?
Yeah.
So maybe your focus should be only figuring out how to get the answer to the first quadrant. And then, you don't need to be neat. You can draw a big circle yourself, right, and just fill in the details in a few minutes, and it's good to go. That help?
Yeah.
Okay, anything else before we get started with our first question, which I believe is going to be the car wheel turning and how many revolutions one. Right, now, do you see this guy over here who's also me with my hand wiggling, this guy here? If you move your mouse pointer over it, do you notice there's 3 dots attached to it? See that? If you click on those 3 dots with the left click and you choose pin video to first screen, you should be now looking at a big version of that piece of paper. Are you all good? I can't
The paper?
hear. Yes. So you should be looking at a big version of the paper now. You got that?
No, it just pinned my face.
Well, go to the screen that has the paper on it. Top right-hand corner, there's 3 dots. Left click on those and pick that guy's the one you want to pin. Looks like you went to your own name and pinned it.
Oh yeah, I did. I'm definitely dumb.
No, you're not. Okay. So are you going to the paper and pinning that now?
I have no idea what we're looking at here.
Okay, who's no idea? Skylar?
Yeah.
Right, here we go, Skylar. I'm going to unpin this for a second. Are you seeing all the pictures? There's about, 12 of us all together. Are you seeing that?
Yeah, up at the top of the screen.
Okay, that works. Can you see the one I'm calling the piece of paper? Is that one of your choices? If not, could you scroll across till you do find it?
Oh, yep, there we go. Okay.
Right, now, move your mouse pointer so it's over that particular mini screen.
Gotcha.
You see the 3 dots that you now have, they're blue and white dot thing? Left click on that with your mouse.
Okay.
And you'll see a choice there, pin video to first screen. Do you see that?
Yes.
Click on that and you should be looking at a big version of the piece of paper.
Oh, okay. Sweet. There we go.
We got it? Everybody else, or are we good? Right. So first things first, let me find the question. And it's this one here. Now, as I said at the beginning, but not everyone was here at the beginning, you do not need to write any of this down because this is a PDF that will be put online and you can look at it in your details. What you're going to hopefully get out of this is just my thought processes about why I did what I did. So the question says, how many revolutions? That's another way of saying, how many times does the wheel turn when the wheel has a diameter of 28 inches and it travels for 3 miles? So, being a kind of visual learner, I like to draw pictures. Here's the wheel. Its diameter is 28 inches and it's traveling, although that's definitely not to scale, it's traveling 3 miles. And you can imagine the wheel going round and round and round and round, right? If that was one of the wheels of a car, right, you could imagine that it might go, I know, a couple of thousand turns to travel 3 miles. So, I'm thinking, okay, what do I need? Well, I need to find some conversions. The wheel is in inches, but the distance is in miles. So it makes sense to me that we would do this question by doing it in miles and converting it into inches. So 3 times, and here's your first question of the day. How many feet are there in a mile?
5,280.
That was far too fast. You were on top of it there. I was checking it myself because I couldn't quite remember. Right?
Yeah, the imperial system is just kind of terrible.
Yeah, agreed.
Do we have to have that stuff memorized for like tests?
Well, you know you're online, so you can always nip online and see how many feet in a mile, and you'd get it within a few seconds, right?
Yeah.
So it's not a big area. It's helpful because if you know it, you don't need to waste 2 minutes finding it out. That's about the only thing. Right, why did it's pretty obvious, but just ask it anyway. Why did I finish with a times 12?
Converting into inches.
Yeah, because that's only feet. You know, that calculation there is just how many feet there are in 3 miles. That's how many inches. Now you might think that's nobody's going to do that. Well, let me tell you, I forgot. The first time I did that, I forgot the times 12. And then I got my answer and I thought, well, someone else mentioned it to me. Hey, what happened to the times 12? And I fixed it. So it's dead easy to do that. Now, this is a big messy calculation, which is why we have calculators, but I think I've already got that one done. So, oh no, I haven't. Okay. If anybody's got a calculator handy, tell me that. Otherwise, I'm just going to put in a random answer as a placeholder for where the real answer would go. So why someone might be doing that.
190,080.
Okay. Then what am I going to do? Well, I'm going to find out what the circumference of that wheel is. Because you imagine if the wheel turned once, wouldn't that transfer into a certain distance that one revolution would be the same as? So the circumference of a wheel is pi times its diameter. In this case, pi times 28, which I'm just going to leave as 28 pi. I know it's a decimal, but I don't care about that right now. And it's also in feet. Not feet. God, they kicked me out of the chemistry class here. Inches. Right, everything is inches. So that's inches, so is that. Okay, last question, last part. Number of revolutions. 3 miles is that many inches. One wheel turning is that many inches. So if you divide one by the other, isn't that how many times the wheel will turn? And that's the revolutions that you're after. Make sense? Now, you can finish off the details, and I'm not going to in this one, but let me show you a little hiccup. You know you're going to do this in your calculator. Nobody would do that in their head. And you're going to say that if you have a TI-84, for instance, there is a pi button, right? That calculation superficially should give you the answer to this, but it doesn't. And so you can actually do almost everything right and then fail on the last hurdle, and you're doing everything right, and then the books, you're putting your number in and the software saying you're wrong. So if you look at that, you might think, surely that is that. No, it's not. What's missing from this calculation to make it that?
Parentheses.
Yeah, as I call them, brackets. You need those guys. See, Chantel, you're not that dumb. You figured that out, right? Now, you might say, why do I need these brackets? If you didn't do this, this is what the calculator thought you meant the first time. It would do that, which is exactly what you wanted it to do. And then it would take the answer and multiply it by pi. You see why you need the brackets, right? So if you're going to do that, be careful, especially when you're dividing, to watch out for the brackets. So I could imagine you were doing this question, let's say it was a test question, which will happen a week on Sunday. You did all the right work, and then right here, right, you hit the wrong buttons in the calculator, right? You didn't put the brackets in. The answer's going to be wrong. You get a big fat 0 according to the software, but you photocopy this and you send it to me, and I will say, Right. Perfect. Screwed up. So instead of you getting 0 out of 4, you see you can get 3 out of 4. Right. So it's important, even the simplest things like that, trust me, easy to skip, easy to miss. Right. So the next fella we're going to be doing, and then after that I'll throw it open to you because you may not want to choose the same questions as others, is this scary one to do with, wish I could get better focus. This one to do with a poor cow being tied to a rope. Animal cruelty should really look into this. There's a building, they attached it, they've got this guy, and the numbers are A, B, C, D, and E. And of course they keep changing, but in this question here, C is 120. Let's get to A is 30. My question, B is 60. D is 70. And lastly, E is 60. I think my printer cartridge is dying on me, so I'm going to add some lines that are definitely kind of vague. Right, that's a bit clearer now. Can you see what we're really being asked to do is find the total area of all these pieces? Okay, so I'm going to call this area 1, area 2. I wish that line wasn't there because this whole piece is a single thing. It's area 3, and that one there is area 4. So that's where my brain is right now. I say, okay, I'm really looking for the area of 4 different things, and so when I add them together, that's the answer we're looking for. So the total area is the area of 1 plus the area of 2 plus the area of 3 plus the area of 4. Great. Now, do you notice that every single one of these 4 areas are all quarter of circles? Did you notice that? Take this big one here. Do you see that there's a right angle in here? You see that's a quarter of a circle. You see this one called number 2? You see the little right angle, quarter of a circle? See this one? Quarter of a circle. Finally, this one. So if I want to find the area of any of these, won't the answer be 1/4 pi r squared? Right, 1/4 of a full circle. So to me, what this question becomes is, I just need to find out what the radius of this guy is, what this number 2 is, what question, area 3 is, what its radius is, and finally what the 4th one is. And then I'll have 4 little 1/4 pi r squares with different radii, and then I'll add the whole thing up. Now, I won't go into the details because, as I say, I've printed this up, but let's do a couple of, let's pick the first one. The first one I'm actually going to pick is this one, because isn't the radius 120? It's kind of staring us in the face. So that's number 3. It's going to be 1/4 pi 120 squared equals some horrible decimal, right? Okay, let's look at this fella here, number 4. Now, can you imagine this is the cow, right, 120, and it turns to there, right? Now, when it gets from here to here, what that tells me is, isn't this total distance from here to here also 120? And I know this distance from here to here is 70. So won't the radius be the difference between these two, which is what, 50? And so that second one, number 4, is 1/4 pi. The radius this time is 50 squared.
I have a question.
Yes.
Isn't it 1/2?
What, these quarters should all be 1/2? Is that what you're asking?
Yeah.
Yeah, well, let's show you why it's a quarter. If it was a full circle, the area would be that. If it's only a quarter of the circle, It's a quarter pi r squared.
I did the problem and I did it
Yeah.
using 1/2 and I got the right answer. So I don't know if I just did it.
Whoa.
I don't know if I did it a different way. I have my work.
I'd have to see that, but I can tell you right now, a half isn't going to work. It just isn't. And if you got the right answer, sometimes you could do two mistakes that cancel out. Oh, wait a minute. Look, can you all see? I know it's quite small, but my screen is a little bit better. She had 1/2 pi. Or actually, let's show you the formula she was using. I'll give it in its formula. Isn't there a formula that's called 1/2 r squared theta? You remember that formula? That's how you get the area of a sector. Now, it's 1/2 r squared. Theta is the angle. In this question, isn't angle 90 degrees? And isn't theta have to be in radians? And just like she did in that piece of paper, isn't radians 90 degrees in radians pi upon 2? Now, if you do a 1/2 pi upon 2, don't you end up with 1/4 pi r squared?
That makes sense. I just did like extra steps kind of.
Nothing wrong with your method. Totally okay with it. Don't change it. It works well. So, two different approaches, same destination, right? Are we okay with this? I know I haven't finished it, but the gist of the process of finding 4 quarter circles and adding them up, and we've done a couple of them, but there are 2 more still to do, and then you'll be finished. Okay, I'm moving this one if we don't have any comments or questions related to it. Okay, I'll throw this one up open to us. This is, actually that one's covered, because we just did it. Has somebody got a different homework question? Or just a general topic that you're not sure about and might want me
I was
to?
stuck on 12, but that's
Question 12, is that on the same section?
6.1, yes.
Okay, let's
I
have a
almost
look
had
at
it, but I was just off a little bit.
Let's have a look at it. I'm going to have to do a couple of things first. I might be able to get it through share. Let me try. Right, can you see WebAssign page? Right, so we're talking 6.1 number 12. So if I go down to view, you'll get at least the answer to this question, which is not really what you're looking for. Right, here we go. But it's a question like a sector, which is like a piece of pizza, right? Like a wedge of cake, that's what a sector is. Of radius 18 miles, has an area of 353 square miles. And it's asking us to find the central angle, what I would call theta, rounded to, let's see, rounded to 2 decimal places. So here's the entire circle. And the radius of that circle is 18. There is an unknown angle here called theta. But what I know is, because they tell me, is that the area is 353. So let me go back and stop sharing. Right. Are we back to the big version again? Right. So you know the area, this piece of pie is 353. You know this distance is 18. What we're being asked to do is find theta to whatever it was and 2 decimal places, let's say. The formula that Chantel used a moment ago is going to be really useful here, because that's the formula that you use to find the area of every sector. It's 1/2 times the radius squared times theta. But doesn't theta need to be in radians? You can't use degrees. You know, you got to turn it into radians for the formula to work. Now, you've just told us, or this question has just told us, that this side here is 353, and it's 1/2 the radius squared times theta. So far, so good. Now, when I see a question like this, what I see is an equation That's a number, that will eventually be a number, and that'll be theta. So it's like 353 equals 22 theta, right? It's going to end up looking something like that. So let's see if we can take that to the next step. Oh, that's like, yikes, 9 times 18, that's a 2 carries 7. I believe it's 162, but don't quote me on it.
It is, in fact, 162.
Okay, sometimes I get lucky, Olivia. Right, what we're going to do then to find the missing theta?
Divide.
Yep. Now that's the one really ugly looking fraction. And so if you've got the time, you can do it. Otherwise, I'm just going to tell you it's 1 point. No, it's not. It's 2 point stuff. Right, and you've got your answer. That help? Right. You know, there are a couple of those questions. I think there's a version of that that has the arc length. Now, the formula for the arc length, S, right, it's S is equal to R theta. And in some of those questions, don't they tell you the arc length and the theta, and you have to find the radius? Or they tell you the arc length and the radius, and you have to find the missing angle, you know, that kind of, I'll tell you 2 of the things, and your job is to find the third one. That's kind of what's happening here, right? There's a formula with 3 variables, A, R, and theta. And as long as you tell me any 2 out of the 3, can I always find the third one? Right? Just plug in the numbers you know, and then almost always you end up dividing something by something else. Okay, do we have another question? Or else I'll move on to one of my pre-made homework ones. Your choice.
I have a question on 3.2, 6.2, excuse me.
Okay, 6.2, which number?
Just number 3. I just started this before this meeting, so I haven't put too much thought into it, but
Well, we're here. Let's use it. Okay, give me a few seconds. I'll see if I can get to it. We said 6.2, number 3. So it's quite early on. This is, I think this is SOHCAHTOA. It is, right?
yeah, just like finding a side when you're given one angle and one side.
Right. Do you can't actually see what I'm looking at, can you?
No,
Okay.
just
Okay.
the
Right. Let me show you what I'm saying just to make sure that it is the guy you want. There, you should be able to see it now. Can you see the question? Number
yeah, that's
3.
the one.
Right. It's either going to be that one or something with similar numbers, right? So if you hold off for a second, I'm just going to draw a very basic version of that same question. And I know they tell me the answer, which is actually really distracting. It doesn't help me. It confuses me more than anything. Right, so let's stop that. Right. We are being asked to find the value of x, but they want its exact value. So they don't want 1.234, right? They want 5√6 or whatever. So here's my approach. Right angle triangle, SOHCAHTOA. As long as you tell me 2 things, I can figure out anything else you want to know about that triangle. Now, if you tell me, say again?
To what? You cut out for a second.
Okay. If you have a right angle triangle and you tell me a side and an angle, or you tell me 2 sides, I can find all the other bits of that triangle. I can find all the missing sides that are left, all the missing angles that are left. Now, I can do that using SOHCAHTOA. Now, in some questions, you can actually do it using Pythagoras. For instance, if I give you a right angle triangle and I tell you 2 sides, couldn't you use Pythagoras to find the third missing side?
Definitely, yeah.
But wouldn't you still have to use SOHCAHTOA to get the 2 missing angles?
Yeah.
So even in those questions where you might be able to find 2 different ways to get part of the answer, you're probably going to use SOHCAHTOA at least once in the puzzle. So in this question, I'm going to use SOHCAHTOA. And first thing I'm going to start with is naming the sides. That's important for SOHCAHTOA. This angle is the angle that everything's going to be named from. This is 30 degrees. This side over here is called the opposite. What's the side called X? What's its
Adjacent.
name? Now, in this question, and I'm not going to write it down, this long one, the one that's furthest away from the right angle, isn't the long one called the hypotenuse? Right.
Yeah.
But in this case, it's a good idea not to write it down because it's actually a distraction if you do. Only write down the names of the things you know the length of or the thing you're trying to find the length of. Only write the names of those two sides.
And
Now,
then
do
I
you know
wrote
it?
down that
Keep going.
the third angle was 30 degrees as well.
Well, that won't be.
I don't
That'll
know
be
if I
60.
need it.
That angle won't be 30, it'll be 60.
Oh, because 90. Okay,
Yeah.
that might be where I messed up. I might just made it some. Okay. Because
Okay,
I kept
well-
putting the. Okay, I got
Right.
it.
Even if you did put that 6 in, let's not, because putting in the hypotenuse and calling it that, or putting in missing angles, actually distracts you from how to solve it. It's actually better to keep it minimalist. Right. Now, because I've only named these two, which one of the SOHCAHTOA combinations uses an opposite and an adjacent?
Tangent.
Does it? Right, tangent. You notice there's only one guy. Now, if I'd named all the other sides, you see, you'd be hunting, oh, I could do this one or I could do that one. You know, you wouldn't know which one to do. But because I've only got these two involved, I can say the sine of angle theta is the opposite over the adjacent. That's the,
Tan.
yeah. Start again. The tangent of theta is the opposite over the adjacent. You're right. Which is that one there. Then I proceed to put in the numbers I know. The opposite is A, but A is really 7, so I'll put 7 in, and the adjacent is X. So do you see we're back to that classic math situation of I have 3 things, but 2 of them I know and 1 of them I don't. I know tan of 30, right, and I know 7. Right, they're numbers. And I only have one thing I don't know, which is X. So typically I do this. Now, why am I putting that extra 1 in? Because it's a clue to what I'm about to write next, isn't it?
Are you going to cross multiply?
I am. I'm going to cross multiply. And in these kind of questions, cross multiply is pretty much guaranteed. So you're going to go X times the tan of 30 degrees is the same thing as 1 times 7, which is 7. And what am I now going to do to find X?
Divide by the tangent of 30
Divide.
degrees.
Correct. So far, so good. Now, just when you thought you were out of the woods and you finally got to the end of the journey, the question wanted to know the exact value. If the question said, give me it to 3 decimal places, wouldn't I be grabbing a calculator right now and start hitting some buttons? But they don't want decimal places, they want exact values. So that's where we have another issue. And this brings us to the unit circle again, Daria. Here's our unit circle. Remember that guy? I'll try to find my little copy of him. I'll probably put it somewhere where I can't find it. There's the 30 degree mark, right? There's a little coordinates attached to 30 degrees, is there? Well, I'm not saying is there, there is, right? So, root 3 upon 2, 1/2. You trust me on that? On the unit circle, 30 degrees gives you the point root 3 upon 2.5. Why is that going to be important? Well, that's an x coordinate, that's the y coordinate. Won't the tan of 30 degrees be the y coordinate divided by the x coordinate?
How would we know that though? Do we just
It's in the notes. If you read over the thing, it says
do like all the different
sine,
degrees?
yeah, for all the way around the unit circle, right? So if you want to find the sine 60 or the cosine 120 or the tangent of 330, right? Anything that's on the unit circle, you take the y coordinate and you divide it by its x coordinate, and that's how you get the tan. If you want to get the cosine of an angle, it's the x coordinate of the point. And if you want to get the sine of the angle, it's the y coordinate of the point. So that little unit circle that we're wondering about, why is it so useful? Well, inside that circle, isn't there a ton of information about exact values of lots of nice angles, right? It's in there just to be kind of sucked out when you need it. Now, do you know a half over root 3 eventually becomes 1 over root 3? You know, different ways of doing it, right?
Yeah.
So what have I got here? I've got 7 over 1 over root 3. Do you think that's going to be accepted as an exact answer? Or do you think that's ugly and won't be working?
Multiply by the reciprocal.
Yeah, you could multiply by, well, that guy, right? And so that's what you would type in, 7 root 3. Okay. Now, as I think I mentioned earlier, somebody in the other class said, if you type in the decimal version of whatever 7 root 3 is, and I have no idea what that is, 8.234, right? The calculator, the software will probably say you are correct, and you will get the point for it. But that is bad math, right? So you always want to get the exact value. So write down what it asks. And it's just good math, right? I didn't write the software, and I can't fix it to make it so that it'll force you to do the exact value. But it's still important that you do. Okay, we got about maybe 2 more questions left. Is there a Daria? Can't hear you, Daria.
Oh yeah.
Go now.
I have a question regarding, okay, I need to get it. Section 6.3 at 18.
Whoa, you're almost done. That's good news. Okay, let me find that for a moment, and we'll see what that's like. Now, if you haven't reached this, you might want to pay attention, because it'll save you a whole load of grief when you do get to reach it. Yeah, before I go into that, do you know this thing I was talking about earlier, this quiz here, online quiz, section 6.2 and 6.3? You're just going to do that the usual way. You do not need to upload working or send me anything, right? Just do it like it was a homework question. Just be a bit more careful. Right now, back to your guy. Let's view number 18. Yeah. The one they've got here is rewrite the cotangent in terms of sine. What's your version like?
Well, okay, shoot. Mine says,
It don't matter. I can use this one if you like.
Find write the first trig function.
Yeah, as in terms of the second. So we'll assume it's this one, right? So this one is cotangent in terms of sine. And then the bit at the end might not seem important, but it is. So let me show you what that guy looks like.
I just don't know what that actually means.
Right, well, I'll show you. It's wanting us to find a formula that's got the same value as a cotangent. Find another expression that's the same thing as a cotangent. But the new formula, the guy that's going to go over my finger is, can only have signs in it. So here goes. If you go through your various lists of what are called trig identities, you will find the cotangent.
Yeah.
And in that cotangent, there are 2 different versions of identities.
Yeah.
One of them says that the cotangent is 1 over the tangent, which it certainly is. And the other one says that the cotangent is the cosine over the sine.
Yeah.
This is the one I'm going to use. Why this one? Because at least it has got a sine in it. This one doesn't have anything with a sine in it, right? So I'm picking this one. So it's going to be the cosine of theta divided by the sine of theta. What's wrong? Well, this is what's wrong. That's a cosine. I don't want a cosine there. I need something that has sines in there. Any kind of sine will do, right? 5 sine theta, sine square theta minus 42. But it has to have sines in it, or sine squares, or square roots, or something. But it has to have sines. So I'm then going to look, and I'm going to find a trig identity, which is what we call these connections between the trig functions. So in this case, sine squared plus cos squared equals 1. Actually, an awful lot of people know that for some reason or other. Did you all see that somewhere in your life and can't even remember why you know it now? Sine squared plus cos squared equals 1. Okay, it's new for some of you, but it's a pretty useful thing. So what does that do? Well, if you rearrange that, isn't cos squared 1 minus sine squared? Right? Right, if sine squared plus cos squared is 1, then cos squared is 1 minus sine squared. Now, I'm almost at the point where I need to be. What is the cosine? How would I get it?
Square root, or I don't know.
Yeah, no, stick to your first answer. Square root of that guy, right? Here's something a lot of people forget. When you take the square root of both sides, isn't there actually a plus or a minus? Suppose I said to you x squared is 9. One of the most common mistakes people do is, oh yeah, x is 3. But actually isn't it x is 3 or x is negative 3? Plus or minus? So I'm going to stick that here. Now, I have a cosine. Whoops, rewriting myself here. I have a plus or minus the square root of 1 minus sine squared all over sine theta. And then you're saying, hey, are we finished? No. I've been ignoring a piece of information. Now I'm going to use it. Theta is in the second quadrant. Remember it gave you that in the question and you're thinking, why did it even bother telling me that? If you do all sine, tan, cos, and this is called the first quadrant, this is called the second, over here's the third, and finally there's a fourth. If you're in the second quadrant, right, you're in here. All of the angles, all the trig ratios are positive in the first quadrant. Only the sine is positive in the second. Only the tangent is positive in the third. And only the cosine is positive in the fourth. So if we have an angle in the second quadrant, it's here. What's a cotangent in the second quadrant? Well, a cotangent is just like a tan because it's 1 over a tan. So it makes it negative. So you put that package together and we use the negative square root. Suppose the same question had said it's now in quadrant 3. In quadrant 3, isn't the tan positive? But isn't the cotangent, which is just 1 over the tan, also positive? Right. So this all sine tan cos, the fourth they tell you what the sine, cosine, and tan does, but really indirectly they tell you what all 6 trig ratios do. And if that had been the case, I would make that a plus. Did that help, Daria?
Yeah, that is complicated. Wow.
Well, it is complicated, or it's less complicated than you thought?
That was complicated than I thought. I didn't think about like squaring signs and stuff like that.
Doing all that stuff.
Well, like what I got wrong was like I think like y divided by x, because I thought it was like, oh, did it have to do with like that weird like yxr thing? So I wrote that one, and then I was like, what?
That would be hard to get out of, because y and x, none of them have theta, and they definitely don't have a sine theta in them, right? So
Well,
that probably wouldn't have been a good road to go. Okay, we got one last question. I think I'm going to choose the question, if you don't mind. And one of the questions I got was, the homework questions was, a 20-foot ladder or 24-foot ladder, depends on the version you got, against the wall, which was number 10, or an airplane is flying, an angle of depression question. Either one of those two, but I don't have time for both. Any preference?
Angle of depression.
Okay. You might, in fact, you certainly can't read this, so let me read it to you. An airplane is flying over an elevation. So here we go. There's the ground. There's the aircraft. Draw pictures. Its elevation is just a fancy word for how high in the air it is. Aye, aye, aye. 5, 1. It's my eyesight. 5,150 feet, right? Now they talk about two cars. There's one car over here, a different car obviously on this side over here, and they talk about the angle of depression. Now you imagine an invisible horizontal dotted line. The angle of depression in the first car is 34 degrees. So can you imagine that you turned and you had to look downwards to there? And that angle, that's the 34 degrees. That's the angle of depression. Now, if you're on the ground, totally different question. If you're on the ground and you look up at a bird, that's your horizontal. That's called an angle of elevation, right? You're looking upwards. But if you're high and you're looking downwards, the angle of elevation is this fella. Now, why is that important? The triangle that I'm going to be using to get all my missing values for, and in particular, that guy there that I'm going to call X, it's this angle I need to know. Now, that's 34. How much is this guy?
$56.
Okay, correct. What did you do to get it?
I did something crazy. So I the first time I think I did the tangent.
Okay, here goes. This guy up here, it's very badly drawn, but isn't that a right angle? And don't right angles add up to 90? So if one piece is 34, isn't the other what's left, which is 56? Right, add up to 90. They're called complementary. Right, if you go the other one, the one that's going down this way, it's 51 degrees, the angle of depression. But the one that we're going to use is 39 degrees. So that picture pretty much contains what we need. So what I'm going to do is only see this one, and then you do the same one for that. So if I just pull out the information that we need, I want to find this side. This guy is 56 degrees, and this distance here is 5,150. And this is a right angle, right? Because the ground meeting a vertical is always right angled. Now, you know two sides, or at least you want to know something about two sides, and you know an angle. So this guy is called the opposite, and this guy is called the adjacent. The SOHCAHTOA that uses opposite and adjacent is the tangent. So the tan of 56 degrees is X over 5,150. And if I do a little cross multiply, we get that one, right? And I have no idea what that is, but we're running short of time. So can we pretend it's 32? Now, you then build this triangle. You go through a very similar process. Let's pretend it's 18. I know it's not. Then won't your answer be 32 plus 18 and you get 50? So that's the process for doing it. So if you're in a section that's all about right angle triangles, then you're pretty darn certain that most questions are going to be SOHCAHTOA connected to right angle triangles. And your job is sometimes just to draw the picture to help you create the triangles that you need to answer it. Okay, we're about to finish off here. Is there any other questions that we need to worry about before we start tidying up and closing it? Oh, what a cool dog you got, Chantal. What you got?
He's a lab mix.
Okay, I can see the color might be lab, but the face isn't.
He's mixed, but we're not sure what he's mixed with.
Has he got, I can't see his body, has he got a slender body? Is it a thin?
He's thin, but he puts on muscle easily.
He might have a bit of greyhound in him. I don't know why I think that, but he might.
He is really fast.
Well, that might explain it. Yeah. Okay, any questions apart from Chantal's nice dog? Yes, Daria.
It's more of like just kind of more of a general question. I was like on section. Can you hear me?
Yeah.
Okay, I was on section 6.2. I need to like find out. I need to quickly get the question because I got the question right, but I don't know if I did the process correctly, and I just like it was.
I would think if you get the question correct, 9 times out of 10 you must have been doing it right, and 1 out of 10 you just got lucky by doing 2 mistakes that cancelled out.
Yeah. Dang it.
If you find it, you can always shoot me an email and
Yeah.
we can talk about it then.
Okay.
Anything else?
Oh, I
apart from that?
found it. Sorry.
Okay, go for it.
It was 6.2, number 3 actually. Well, actually no, never mind. Oh wait, you already, never mind. I got it. Never mind. I think you already did one. That one.
I've got a feeling it's scary inside your head sometimes because there's 2 people having an argument and I'm not sure which one's going to win. Your brain's
Like,
your brain almost as bad as mine. I do that so often. So we're sharing a brain here.
the thing was, I thought, because I got like the first question wrong, so I had to like do the resubmit, and then I figured out they were doing like the 30-degree thing. So I looked at my notes and see like what it was just, I don't know, and then
Right,
I just timed it by 5 or something.
Get familiar with standard angles. If you ever see 30 degrees, 330, 135, 120, angles that look like that, if they are in the unit circle, they're called standard angles. You ever see one of them, grab your unit circle if you've not already got it and stick it beside you and say, there's probably something in that unit circle I'm going to be using any minute now, any second now. Because if there's a sine or a cosine of that angle, you're going to get the exact value straight out of there, right? Root 2 over 2 or minus root 3 over 2, whatever it is. Okay. Oh, excuse me. That's better. I'm ready to go. I'm going to have a much better weekend than you lot because you are going to get all this stuff finished for midnight, 11:59 tonight. Not tonight, 11:59 on Sunday night, but it's slowly getting there. So hopefully that's good. The video for this is going to be online. If you look at Canvas, you'll find it. And the PDFs that I keep talking about, which are some of the written solutions, I'll put them on that same page. So there's probably going to be a page, you might go hunting for it, and it'll be called Zoom Office and Class Thingy Bob or whatever name I come up with. And go to that page and scroll through it and you'll find what we're talking about. Okay. But have a nice weekend, stay safe and have fun. Okay. Bye.